All right. Share the whole my screen. Can you see my screen?
Yes.
Yes, sir.
All right. So I guess Git is just one of the things that we work with every day. But most of us treat Git as just like some sort of like a simple versioning tools that you have to use to maintain your code and all that. But there are a lot of Git utility tools that you can use to help you in better structure your code or better sort of revise your code, and you can roll back anytime you want that kind of thing. So let's say, for example, if you screw up certain files, you can always easily going back, even if that file is being committed to master already, which is very useful. So in this quick training, I'll just going through the basics, like how Git works and some useful commands that you can use. All right, let's go into it. All right, so pretty much Git is a one-directional a cyclic graph, so which means it cannot form a loop. So if it goes from head down to branch, let's say if you go like commit next to commit next to commit, you wouldn't have a loop. So if it goes, it's always go down. Does that make sense? Like it always go down, doesn't go up. So if it has a parent head, then that's the child commit, and then there will be child commits and all that sort of stuff. So it always go down and it doesn't go up. And there are three types of objects. The first thing is commit, which contains the author, the message, and also the pointer to the tree. And then the tree has a list of basically file names or other trees. And then the blob is just data. So if you see a blob object, it only contains data. It doesn't even know about file name or whatever. And also the tags and branches are pretty much just pointers commits. So there's no special there. So instead of a commit that you see is like a char hash text, then the tags and branches are pretty much just giving it a name, and that's it. So that's just three different object types, and then what are tag and branches. So basically, if you go into NPM or Composer, when they package things up and then they put like a new version, essentially they just create a new tag to that particular commit or to the current master, and then they zip the whole repository and they publish it, and that's all they did. So the tags, the version that you see in NPM is pretty much just tags, and you can use that tags to refer back to a commit inside that repository. So like I said, it's just a massive directed acyclic graph. So what I meant by that is that from A you can go to B, C, to B, to D, and to E. You can't have something like A, B, C, D, or A, B, D, C in this case. So that would form a loop, and that doesn't work. So we don't want to do that. And a commit always have a parent commit, which just points to the previous commit where the current commit is based on. This helps us in versioning in a way, because if we know what commit is the parent of this commit, we can always go back to that one and revert the changes. And that's how versioning works. So let's say, for example, this one's 1.0, this one's 1.1, 1.2. So pretty much you can roll back from 1.2 back to 1.1 and to 1.0. So essentially, you can always go back to some commit in the past, even like no matter how long, how far away in the past that is. You can even roll back a project, like if there's like a project for 5 years, you can roll back 4 years ago. That's fine. So it's still possible to roll back. So you can go back as far as you want up until, of course, the first commit, as always. And the first commit, obviously, it won't have any parent, which is why it's a special commit, because it just doesn't have parent attributes. And the head is just a reserved keyword, which points to the latest commit in that branch. And this is what I meant by forming a loop. So you can see you're going to go from here to here to here to here. So it's forming a loop, and that doesn't work for Git. All right. Is there any questions so far? I guess not. Okay, let's moving on. All right. So to be able to understand how Git works, we need to understand what are the hashes that they're using. So pretty much, because I already mentioned before, there are 3 object types: commit, trees, and prop. And each object, it's basically just a file name. And Git technology use 40 character hash as the file name. Technically, it's not, but it's more like an object identifier, because Git normally use 2 first character as a folder, and then the following 38 character as the file name itself. You will see that in the demo when I run it through. But because 40 characters is so long, so normally they only use about 8 to 12 first character as a shortcut, because it's unique enough. When the project getting too big, then it will start having more characters to make sure the commit ID is unique. But for a small projects, then I think it start at 8, and then when it goes to like 3 to 4 years with like active commits, then it will start increasing the first character to be able to make every commit unique. It's just a shortcut, but because the real ID is 40 characters, so I don't think we will get to that level anytime soon. And this one is just interesting. So if you want to know more about how Git works under the hood, you can just run this command. Basically, it will let you see the contents of each object, which we will get to very soon. And yeah, let's play with Git a little. So at first, I will show you our Git. So just to show you a little bit about what I meant. So for example, if I go into this repository, so you can see this one is a commit shortcut. As you can see right now, it has 1, 2, 3, 4, 5, 6, 7. So it uses 7 characters now, and it's not even 8, because our website, our repository is just, it doesn't have enough commits. It's like I said, it's like you see here, it only has 60 commits, so it doesn't even need to use 8 character as a shortcut yet. But nevertheless, this one will point to that particular commit, and then you can see about 40 characters here. And this is the full length of the character, but it only needs to have the first 7 commit to be able to distinguish the 60 commits. So the hash is very, it looks very random, but there's algorithm to it to make sure that it's unique. And yeah, it will point to, it will be like, if you're just referring these 7 characters, it will refer to a unique commit anyway. Yeah, so that's what I meant for shortcut. Anything I want to show you before we go into the demo? No, I guess not. All right, that's good. So to be able to run the demo, I have certain setup here. So I think first I will create a project first. git demo. Okay, I'll go in there too. And I will track the file changes in this folder while we are doing things. So So what this command does, just run this command every 1 second. All right. So right now it's empty, as we can see. Now, if I do git init, then it will create a bunch of files and stuff that right now we don't really need to care that much. And just because we don't need these kind of hooks, so I'm going to remove them. Oops. All right, that's good. And just to keep it like smaller, so all right. Now, if we create a new file, so let's say file1 content. All right, so you can see that there's file1 here created, and there's nothing changed in the Git folder yet. Now, if I do a git add, then you can see that there's one object being created. And before I mentioned that Git used the first 2 characters as the directory folder, there's a reason behind this one. I think apparently this is more like a legacy reason when the machine was a lot slower and less capacity. Then because if you keep everything as a 40 characters in a folder, then that folder will potentially hold like millions and millions of files, and that slow down the whole thing because of the index. So to put 2 characters in front, it reduced the size of the parent folder and therefore speed up the indexing. But this is the legacy reason. Right now, the computer is strong enough to be able to handle millions and millions of files, but still they keep it as a, I guess they just haven't made any change to it because there's no point to. So just keep it the way it is. All right, so this is the first thing. We can have a look and see what is in this one. So like I said before, we're gonna use that git cat file things, and -p is the content. So you can see that that's the file content right there. Wait, did I? Yeah. So it's the content of the file one, but there is no name. So it only holds the content. And we can see the type of this object by changing into -t, which is standard for type. And it's just a blob. So before I said the blob, it's just the data. So it only holds the data. It doesn't care for files or whatever. And so where are the file names? So basically, this one is a new file. Therefore, it hasn't been committed into Git yet. So where is the stage? Where you can see the stage content? It's in here. So .git /index. This is where you have the stage. So if you cap that file, you can sort of see it. It's not plain text. It's more like a binary, but you can easily see the file one name is here. So this is the git /index is basically where the content of this file is, right? So all right, let's go ahead and commit it. Oh. So you can see that apart from the first commit, 7eve something. So this one is the first commit that the first object. So it's still there. Now Git adds 2 more in. And what are the 2 more? Then we will have a look right now. So let's say I want to open this one. Actually, I want to see the type first. So the type of this one is a commit. Let's see the content. So if an object is a commit object, then it will contain the tree, the author, the committer, and also the commit message. And that's all it holds. And the way it points to data is that it contains a referral to this tree here. And tree is just another commit. And if you have a look, then this tree EF743B51 is that object right there. So basically, object refers to objects. That's how Git works. Now let us have a look at this tree. We already know that it's type tree, so we only want to see the content now. So the content is basically the file permission, the type, the SHA, and the name. And the SHA here refers back to that file, which is a blob, which contains the file content, right? And that's how they point back to the file. Now, what if I create a new file? So if I do winfile2, nothing changed here. It still have 3 objects. Just don't let the flashy things concern you. We only care about how many objects are here. So we have 3 right now because the file2 just get created. We haven't added them in yet. So, just to make it more interesting, I'm gonna edit this file so that you know how Git treats the editing files. I'll just say that, save, do a git add, and now we have 5, which is logical because it just created 2 more objects. So we added 1, we edit 1, so it's logical to have 2. All right. So we did 2 actions, then it should have 2 new objects basically. Now let me commit this one. All right. And you can see here it split out into 1, 2, 3, 4, 5, 6, 7, which makes sense because every commit it will add 2 more in. One is a commit blob, one is a commit object, the second one is the tree object. So let's have a look at this commit right here. So it's already show us the SHA of the second commit, which is good. All right, so this is the second commit. And you can see this points to a tree. It has a parent now because it's no longer the first commit. And from now on, you see every commit will have a parent, which points to the previous commit or previous commit. So let's have a look at the tree. So there's no surprise here. It will contain these 2 blobs. Keep in mind that the file1 blob is different to the file1 that we had before. So for example, this one right here. So the blob is different, right? The ID is different now. That's because we updated the file1, and now it points to a different blob. All right. So let's have a look at this blob right here. What does it contain? Yep. So it contains the data that's the updated file content, and of course the second one would be just the content of the file too. Okay, now this is where you probably will see why Git sort of manage data in a way that it is so fast to retrieve the latest code. So to do that, let's say we create a new file. All right. We add that. We have a look. That's only one file. We haven't touched the other two files, and now we commit. All right, now let's have a look. So same thing, have a tree, we have a parent, or as always, and this parent is basically the previous commit right here, 7EEB, 7EEB. So that's nothing special there. Let's have a look at the tree. Now, we only add one file, but the tree contains everything. And basically, this is why if you check out a branch, like another branch, it is so fast to basically update the whole repository. It's because every time you commit something, it creates a tree object that contains every file, every pointer to the files possible. All right. So basically, even if you commit like some tiny small thing, it will populate the tree containing all that anyway, so that it can refer to that one every time if and when you need to check out that commit. And we will not go into Git compress and all that sort of stuff right now, which is how they save space in the local repository. But yeah, at some point, if you don't compress, then the whole .git folder is going to be really massive. But basically, that's how Git manage your file and all that. So with this knowledge, you can pretty much go back to any commit that you want, and then it will just check out all the files that are in this tree. And because it only contains the SHA, the file name of each object, so it can always go back to this object structure here, pull out the content, and then applied it into the folder directory. All right. Yeah. Is there any questions so far? We'll continue then. Now, so now we know how does commits works. Let's go to branches. So as you can see, I'm in branch master now. I will check out another branch. Branch. All right. And I will have a look at the ref of this branch. So I just check it out. And the head, like I said before, the head is just a special pointer to the latest commit in that branch. So if I open this, I should be able to see that hash. So that hash is basically where this branch is pointing as the latest commit. All right, and this one, it should be a commit basically, right? Simply because it points into that from master. So so let's say, for example, if I check out this commit right here, I will be in a detached state. And then if I check out a branch from this commit, then the head will be pointing to that one. So let's say first commit branch, right? So you can see that there's only one commit here because I check out that commit first and then I create a branch, which means the branch now will have their head pointing to this commit instead. So you can sort of change the head depending on where your branch are. And this is, I guess this is causing the most confusion because let's say, for example, you have a master branch and then the master on the remote repository, let's say on GitHub, has been updated. But in your local, it's still the old head. And therefore, any branches that you create on your local before you do a git pull on master will always be in some old commit that is not the latest master, which is why you need to check out the master, pull the latest branch, and then do whatever you want with it, just to be sure that it's up to date. But yeah, that's basically how Git manages branches. All right, now, just to show you some more stuff, I will create maybe about, probably about 100 file will do. Yeah, don't. What I'm doing now is just automatically create, about 100 files using the command line. So as we can see, it's like just create like a bunch of stupid files there. All right, now let's have a look. I'll add everything in, commit that. Okay, now let me see what commit SHA am I having. I have that one, so I'll clear that. All right, so same thing, same deal. It's a commit object. We have a tree, we have a parent and all that. And then let's open this one. All right, so it will have the file one because we are in a different branch now. We are in the first commit branch. That's why it's only have file one. If we were in master, it will just have all the files. But what I want you to see is that all these files basically have the same hash. So we created 100 files, but essentially there's only one object being created. That's because it all have the same content. So all these files always have the same content, which is the stuff thing that I put in. So to show you, so I just have that text, and it all have the same content, so therefore it has the same hash. And that's how we sort of save a little bit of space there. It will hash the file first, and then if it has the same hash, then it doesn't create a new one. Cool. All right. Are there any questions so far? Okay. Cool. All right. Now, so after we get that, let's go to some useful commands. So the first commands I want to tell you guys is cherry picking. What cherry picking does is that, let's say, I'll go back to this one. What cherry picking does is that treating each of these node is a commit. What cherry picking does is that, for example, if you are in C, and for some whatever reason, you want to check out the files, all the files in the B branch, you can do a cherry picking to take all the changes in the B and apply to C. And that's how cherry picking. But basically, that's like the definition of that command is. So let's say, for example, in D, which go from A to B and D, and then for some reason it needs some stuff from E, right? It can cherry pick stuff from E, put it back to D, and now D will contain D plus E, basically. So yeah, so that's how cherry picking works, and I will show you the example right here. So we have the first commit branch, which is fine. It has the 100 files commit right here. Now, if I go to some branch, right? It has 3 files, and it has 3 commits. Now, I do a Git cherry picking from that branch, and that branch have this commit. So I want to cherry pick just that commit. So it doesn't touch this one, doesn't touch any other commit. It's just touching that commit only. So if I do that, what it does is that it will pull all that 100 files into my branch. It will auto commit that into my tree as well. So remember before we only have the third commit, now we have the fourth commit. And basically it just brings the commit over to another branch. This is quite helpful when you sort of having a base commit for multiple branches. So for example, you set up something and then you want the same setup to be carried over to the next branch, then you can cherry pick the setup commit, bring it over, and then do whatever you want on the new things. So just to show you that it doesn't pull out everything. So this is the what branch is this? This is a some branch. Now, if I do a git add, oh no, git add, sorry. If I do a new file, so this is like a cherry pick file. Right? Some content. Yeah, and then commit. Cool. Now, there's 5 in here. All right. I will check out master. I will check out another branch. All right. Oops. Forgot the flag. Only 3 commits, right? Now, if I cherry pick this one only, there's only 4 commits. So it doesn't cherry pick the 100 files. It doesn't do any of the previous. It's only check out that commit, that single commit only. So yeah, keep this in mind. So if you do a cherry pick, it only pick out that any changes from that commit only. It doesn't care about any previous commit or any next commit, whatever. It only apply the changes inside that commit. So all right, so that's cherry picking. Now, rebasing is what we're using quite a bit in our company. So what rebasing does is that, just go back to this one, for example, consider this graph. And rebasing is that, for example, you have C going to E. Now you want to rebase and C is going from A. All right. Now rebasing is basically changing the parent of a commit, right? So instead of having A as a parent, now I want D as a parent. So what you do is that you just change the parent from A to D, and then resolve any conflicts that cause when you are changing the parent. So for example, if A has file 1, C updates something in file 1, D actually also updates something in file 1, then when you change the parent from A to D, obviously you would have some conflict. Say file 1 has like do A, and then like C has do B. And of course, there's going to be conflict that you need to resolve. And basically, after that, you're going to see something like this. So let's say, don't need this anymore. And then for now, so now we have A, B, D, E, right? So A, B, D. Oh yeah, that's fine. E, right? And then we have A, C, D, E. So A, C, D, E. Right? This is before rebasing. So after rebasing, because C is no longer a child of A, but now it's a child of D, so you're gonna have something like A, B, D, C, and E. So it changed very slightly, right? And but like C is no longer HR, but now it's D char, basically. All right, and to be able to rebase that kind of stuff, what I'll do is I'll check our master. Always check. Yep. Cool. I will create a file. Do I want to do that here? No, I don't want to create files. Anyway, I will update this file one here. File content edited. New edited. All right. Add file one. Looks like it created a few files that I don't like because I did this kind of stuff. But anyway. All right, commit. Cool. Now, check out master. And I also update file one because why not? New something edited. Yep. So this one will probably resolve in conflicts now. So git add. Right. Yep, that's all that. Now, if we want to rebase branch one on branch two, so right now it is something like this. So let me make a new slide because I can. Delete that, delete that. All right. Now, I'll just draw something here. So you have master here. You're gonna have two branches here. And you go here, that's update file one, go here, update file one, right? That's the one, that's the two, and that's master. All right, now, if we want to rebase, or if you want to change this branch, change color, you want to change this branch and rebase it onto this branch. So the result was going to be line master, branch one, and branch two. And it's always an arrow. And this is number one, this is number two. Right? So that's just essential of how rebasing works. You change the parent. So the branch two parent is basically a master. But now we want to change the parents into the branch one. So the way we do that is that make sure that you are in the branch that we want to rebase into, which is branch one. Do a rebase. Rebase minus I stands for interactive, which means that you can do some stuff with the commits that is coming over from branch two into branch one. Origin, branch one. Oops, not origin, just branch one's fine. Wrong one. I mean branch one, I should rebase branch two instead. All right, so now I can see the branch two commits here. And you can do a whole lot of things under here as well. You can sort of do a lot of stuff that you want to do, because normally you don't just rebase just one commit, because this one is on branch, not commits. So most of the time you're gonna see a rebase of multiple commits. right? And then you can do a lot of other things with different commits that you want to change the behavior of. You can change name, reword, all that sort of stuff. For now, we don't have to do anything. We just save. Now, conflicts. So this is expected. And when there's conflict, read what Git gives you. So the message here is basically it tells you what to do, right? So it's say there's a conflict, could not apply, that's fine. Resolve conflict manually. So you have to do it manually now. And then do a git add or remove the files, and then run the rebase continue, and then or do a rebase git. So Git try to tell you how to resolve this thing. You just have to read it, right? And lots of people just don't read. They saw this line here and they already panic, right? Yeah, they just didn't spend time to read any of these, which is where most of the questions are coming from. Like Stack Overflow is like flooded with all these kind of stuff. Alrighty, so how do we resolve that? So now we have a look at the conflict files. In this case, it's only one, but normally there will be like a few of them. And what you do is just to resolve file by file. So after you resolve one file, you do a git add that file in, and then you keep going until everything is resolved, and then do a git rebase continue. Now let us resolve this. So as you can see, we have two of these. All right. And the head one is where branch one edit thing is, and branch two is here. All right. So how do we want to resolve this one? Is up to the rebase person. So in terms of code, then it means that you need to review the code in here and review the code in this section, and then try to merge them together manually. So in this case, what I'm going to do is that I'm going to just add. I'm going to just add that one in, and then delete the rest. And make sure that once you resolve things, you have to delete all these kind of extra symbols and text that Git added in, so that it tells you where to look for resolve conflicts. So what I'm going to do is just I'm going to delete all that. So this one is our new resolve conflict content now. That's done. Now we will git add and git rebase continue. And of course, you have to confirm that basically. And that's done. Now, if you have a look, then the base of branch one is ahead now, but branch two goes underneath, right? So basically, that's how we rebase. Is there any questions so far? I think this one does have some confusion when we were like doing some rebasing in our repository. And I guess VS Code or like Git for Windows or whatever does a very good job on visualizing and sort of make it easier to use Git. In my opinion, it's better to just go into terminals and actually running the command so that you understand how Git works and have a better usage for Git. One thing I want to show you guys is that Git actually contains the history of everything that is going on inside a branch. So even if you rebase and like squash commit and all that, the commit SHA is still there. So it's not gone. So git ref, I think that's, and then let's say first commit here. What am I doing? No, logs, sorry. Logs. And then first branch. All right, so basically, let me do a branch 2 is better. Instead of cat, I'll do a vim, so then it's easier to see. All right, so what it does is that it tells you when, this one is a timestamp basically, when this branch was created, when this branch is having a commit. And I think if we go to branch 1, you can see the revise there too. All right, so it contains all the SHA. It doesn't, it's not gone. So even if you squash, you do anything, then this log will still be there for you. So if you screw up something, you can always go back, check out this kind of commit, and roll back to wherever you were. So you can roll back to the time before the rebase, for example, and then trying to fix stuff from there. So you can sort of save yourself in that sense. So if you screw up on the Git, just remember that there are always Git logs, and you can go back without any problems. Alrighty, let's go to check out a single file. So sometimes you just need to check out a single file. Cherry picking is check out a commit. Rebasing is more like check out and apply the whole branch. But what if you want to check out a single file? For example, what branch am I on? I'm on branch 1, and I have these files, right? Now, I want to check out one of those 100 files in the other branch. I forgot what branch that one was. I think it's in some branch. Is that right? Yeah, all right, cool. So right now, I want to check out, let's say, file number 50 in the some branch, right? What I'll do is that I will run this command here just to check out. And then that branch name, double dash. Double dash, it basically means we will check out just a single file. And then the file name, so let's say that. Okay, now we have that 50 here, just a single file, no history, no whatever, just one single file being copied over. And that file will be automatically staged, but not committed. So you can still make any change, blah, 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 blah. But this is very useful when you want to check out things like config files from a different branch and, you know, certain things. So I'd like you to know about that one. You don't have to remember, but most of these sort of trainings just let you know that the utility is there. And Git can capable doing something like that so that you can Google it in the future when you need it to. Resolve conflict, I think we touched. And yeah, so those are the useful Git commands that I'd like you to know. Of course, like things like push and pull and commits and all that sort of stuff, it's just like too basic that I will not go into. All right, is there any question? I think in that case, that's everything that I want to discuss with you guys today. Yeah, hopefully, if you have any questions regarding Git workflows, feel free to ping me. And if I have enough question, maybe I'll do another training to sort of share the difficulties of other people with you guys. Thank you.
Thank you.
Thank you. Thank you, sir.
Thank you. Thank you. You have a good day.
Have a good one.
Yeah.